Alright, so we're the Robo Maniacs. So this is our research notebook. So whenever we had a meeting, we would write down what we did that day.
Good. Awesome.
Yep. Here's some business cards on here. We're ready when you are.
Yeah, go for it.
Good afternoon. Our team is the Robo Maniacs, and we're excited to be here. We did a lot of research on the problems faced by humans spending a long time in space. There are threats from radiation and psychological stress and sleep problems. But we were really surprised by how many problems are caused by zero gravity and how long it takes you to recover. You lose muscle mass, your bones get weakened, your blood circulation slows, fluids make your upper body fat, your skin gets weaker, your eyesight gets blurry, your brain shrinks, and you even have a higher risk of Alzheimer's. If we could solve the gravity problem, it would really help astronauts live safer and do their jobs better. We did a Google search for artificial gravity in space, but almost every solution was just a big ring that rotates. And all these are science fiction. They're too big to launch on a rocket, and we thought about how hard it would be to launch all the materials into space to build the ring there. It took more than 40 flights over 13 years just to build the International Space Station.
We've seen people spinning buckets of water over their head without spilling because the spinning creates artificial gravity. So we had the idea of connecting two spaceships with a cable and spinning them around each other. But when we Googled it, we found other people have tried this idea too. They call it a tether. The Gemini 11 mission even tried it in 1966, but not for gravity, and they didn't spin very fast. One space shuttle mission wound a tether almost 20 kilometers long to test with a tiny satellite. So we wondered if a manned mission like SpaceX's Dragon could use tethers to make artificial gravity. We met with two engineers, Mr. Chris Bankers and Mr. Ben Latner, and they taught us some basic physics. The velocity of something is how fast its position is changing over time, and acceleration is how fast speed is changing over time. So it's measured in meters per second, or meters per second squared. The acceleration from Earth's gravity is 9.8 meters per second squared.
The acceleration we need is centripetal, or towards the center of a circle. We know it gets bigger the longer our tether is, and faster we spin. The engineers helped us figure out the formula, A equals R omega squared, which has the same units of meters per second squared. R is the length of our tether from the balance point, and omega is called the angular velocity. So to make the math easy, if our spaceship rotated at 0.1 radians per second, which is only once per minute, we would need a tether radius of 980 meters. Or we could use a shorter tether and either spin faster or have less than Earth's full gravity. But we had to find a strong enough material for a tether. At full gravity, it would need to support the Earth weight of our cruise spaceship, say the Red Dragon at 7.5 metric tons. So we searched online and found a fiber called Spectra. That's 0.6 millimeters thick and has a breaking strength of 310 pounds, which is 0.14 metric tons. So 100 of these fibers spread out like threads on a loom could support 14 metric tons, almost double the weight we need.
And a company named Cortland makes rope out of this fiber, and their half-inch thick rope can support 14.2 metric tons. So this would work too. We figured out that if we made a 1 meter hose reel and the tether took 90% of the space, we could fit 22.4 kilometers of 100 fibers, or 5.3 kilometers of the rope. But if we only need 2 kilometers, we have plenty of space, and the fibers would only weigh 60 kilograms, or the rope 190 kilograms. And if we had 2 separate tether reels, that would be a safety factor of 4. So for example, we could let out the tether on its way to Mars, and use a little rocket thrust on each side and just spin for the whole trip. We could even let out more tether to gradually slow down and prepare the astronauts for Martian gravity at the end. We shared our idea with an aerospace engineer, Mr. Brian Thomas, engineering director at GE Aviation in Michigan, and he said it was really interesting, really a cool idea. Our other 2 engineers said it was great analysis, and it's good we are over-engineering it well beyond the tolerance. So thanks for listening to our presentation. Do you have any questions?
Give your round of applause. Do you want to go first or do you want me to?
No, go ahead. I need to So, I guess I'm just gonna start with, why did you guys choose to look at creating artificial gravity? How did you come up with that was what you wanted to do your whole project about?
We looked at the problems in space and we found that artificial gravity caused, zero gravity caused the most problems in space. So we tried to think up of a way to solve that.
Okay. So I know you guys did a really good job explaining what are the effects of zero gravity. So you said 10% of bone mass in 6 months in space. Is that how long it would take to get to Mars or to do a longer mission?
Yeah, so when people are in space, like if they're in the space station, sometimes they're up there like for a year, and that's what it would be about. So,
Okay.
like up in the space station up there where they do tests about space and stuff.
And it takes, I think, 9 months to get to Mars from here.
Okay, so you'd have to be in space obviously longer than that. So it's not, the solution can't just be, let's not spend as much time in space. It's not fun anyway. The one that I wondered about, eyesight can become blurry. How does that happen?
So when the fluids of your body go up because there's no gravity, they go to your head, and that force, because there's more in your head, that force squishes your eyes.
Okay.
So when you come back to Earth and there's gravity again, your eyes can't go back to how they were.
So it changes the shape of your eye.
Basically.
Yeah. I hear it also, if you have wrinkles, it makes the wrinkles go away being in space because of all the fluid in your face, so but astronauts tend to like that.
How did you connect with your professionals that you met with? Is he someone from Oak River and someone from Abbott?
Yeah, so Ben Latner, he's Jonathan's brother, and he works at, where does he work again?
Oak River Technology.
Yeah, Oak River. But then Chris Bankers, he works at my dad's work, so we know him.
Okay, so it's kind of some networking there.
Yeah.
Some connections. Good, okay. And who taught you, or where did you do all of these equations? Or I assume there was lots of math sessions, or?
Mr. Bedler or Mr. Chris Bankers helped us with the math on whiteboards during the time we had a week.
Yeah.
Okay. And then how did you pick your angular velocity? Why did you settle on that specific number?
So angular velocity, that is how fast we spin, I think.
Why not 10? Why 0.1?
Because it's,
we don't want to go too fast or too close, the tether too close to the middle, or else you get dizzy because your head has way less gravity than your feet. So we wanted to make it as long as possible, but still not super long.
If we had the tether short, and we moved fast, there'd be two problems with that. One, you could notice that your head was having less gravity than your feet because it's smaller. The tether's smaller, so you're closer to the middle of the tether, and also you could get dizzier faster. If you have a long tether, your body overall has basically the same gravity because it's a long tether, and you don't get very dizzy. So.
Okay. Are there any concerns with how long your tether is and all of the debris in space? Is there any risk that, I know it's very strong, but maybe something sharp in space could cut through it, or any of that?
They have radars up there, so they can sense pretty big things. So there is small stuff in space that might be able to escape past the scanners. So we wanted a rope that would be strong enough to.
But
that's why we could also have multiple ropes connecting the two spaceships.
And if some asteroid, they didn't see it on the radar and it did hit the rope, they would have rocket thrusters on each side to make it start spinning, so they could just steer it back together and not have gravity for the rest of the trip if the rope broke.
So I'm still trying to wrap my head around. I mean, I understand that you hang onto the bucket and spin it and the water doesn't fall out on Earth. So up in space, you have the tether that's trying to spin around. How do you keep the center point from like going flying off along with the tether as well?
The center point is in the middle of the rope, so these two rotate around,
Yeah.
and so there's like no gravity in space. So they should, if you start spinning it, and
So they'll both move.
it would be going forward, yeah. They
Okay.
would both move, and it would start spinning, and because they would both be pulling.
Like taut, like this.
So-
Yeah, okay.
And if one was heavier than the other, then the center point could be closer to the heavier one, so it doesn't unbalance it.
Okay.
Still the
So they
same
have to-
force on both sides.
And what would you need like to accomplish the force on both sides?
You could use rocket thrusters on both things, maybe one more on the other to get it spinning that certain way.
Okay. And then in addition to also moving in whatever direction, such as like moving towards Mars, would,
So.
would that require additional boosters or?
It would start, first it would launch on the spacecraft, and then this module would go off, and it would be moving towards Mars, and then they could go apart and like get the rope.
Okay.
So they'd already be moving toward Mars, and then it would just like spin all the way to Mars.
Gotcha. So, yeah, yay, momentum.
Did you have any other ways of creating this artificial gravity, or did you go right to tether and then just keep modifying tether?
In our lab work, you might have seen it. We had some other ideas of creating artificial gravity, like using bungee cords to strap yourself to the ship with, like, let's say, wheels or something, and then you can just slide around with gravity. But it would be very difficult, and the tension on each side would be very difficult to balance out. And this seemed like the best idea.
And also, like, if you have bungees, it's kind of hard to get it at the very top of your head to like give all your body gravity. So I mean, most for like exercising, they had like a bungee from their waist down so that their feet would go, but then you're still in zero gravity, like
I
you're up
can
and around.
also add to that. So, if you had bungees, then it wouldn't help fix the problem of fluids rising in your body or any of that, because you'd still be in low gravity. You would just be being forced to walk on the spacecraft.
Can you tell me more about the Honeywell Spectra fiber? Like, what is that used for on Earth or?
Oh, that's actually used for, we requested a sample of it because they were like, we'll give you the sample. But then they emailed us back and said, this rope it's like private because we're actually using it for like bulletproof vests for like the military because it's so like strong.
Okay.
So, yeah.
So they couldn't send you the sample because it's already classified.
But they could maybe send us the Cortland fiber sample because that makes rope out of that fiber, and you can't really make a bulletproof vest out of rope. So we still haven't heard back from them. But.
Are there other solutions? I know, like I hear the carbon nanotubes thrown around a lot that you could use for a strong tether.
Carbon nanotubes have not been produced enough, and I think they're very brittle, and people haven't made them into a rope yet.
Okay.
And it would be really hard to get it like really long because there's not that much of it.
Okay. Is there anything else that's like super strong that you looked at that is a possibility for?
Vectran, carbon fiber, and other fibers that are very strong.
We started looking at steel, but it wasn't strong enough.
Okay. You mentioned a little bit about that you shared your idea with Brian Thomas.
Yeah.
Did you share with anybody else?
Well, yeah, we shared it with another team that's
Okay.
here.
Okay.
Like with 3 people and then the team here. But we shared with like 2 engineers and like a space airplane person. So.
Okay.
Yeah, we're planning on maybe sharing it with other people.
Like a NASA engineer, that'd be cool.
Yeah. Or even just a SpaceX person. I mean,
Yeah.
like you have SpaceX
Yeah.
and your poster, so. I don't have any other
I
questions.
have no more
so-
questions.
Yeah, thank you guys. It's good to see you
Good
again this year.
job, yes, you guys did good.
Thank you.
Same. No good.
Yeah,
Thank you, thank you.
Spot.